everyone, in this video I would like to explain how to find for the number of ways you can color this dodecahedron. Again, there's 5 Platonic solids and this is one of them, and these 4 are the rest. This dodecahedron has 12 faces or 12 pentagons, and I'm going to explain how to color all of the faces of this dodecahedron using 2 methods or 2 ways. One of them will take longer and one of them will be easier and faster, just a little bit I think. So the first way is the longer way. So if we put the top way, if we choose any face from this dodecahedron, and let's say I chose this face, okay, this pentagon, then I would put it like this. So this is the face that I chose, and now the exact bottom of it, which would be this one. So this is the bottom of this dodecahedron I chose, and I already color the top pentagon with a color already. And now how many colors can go on the bottom one? Well, we have 11 faces left, so that would be 11 choose 1. Multiplied by, this was the base or the bottom part of our dodecahedron, and now we have 10 faces left to paint, right? We painted the top and the bottom, and now we have 10 left. And the part we want to paint next are the bottom 5. So this one, this one, this one, and this one, and this one. Not the top 5. And since we randomly chose the top and bottom parts, we're also going to have to choose 5 from the 10 left, because it wasn't already, the top and the bottom wasn't already chosen to be them, I guess. So we still have to choose the 5 from the remaining, which is 10. So we have multiplied by 10, choose 5, multiplied by, and since we chose the 5 to go on the bottom, this one, this one, this one, this one, and this one, those 5 can be mixed up, but it's the same problem as trying to find for the number of ways you can arrange 5 people to sit on a circle table. And that would be 4 minus 1 factorial. I meant 5 minus 1 factorial, and since we have 5 faces here, it's the same problem. So that would be 5 faces minus 1 factorial. And then we have 5 more faces left on the top. 1, 2, 3, 4, and 5. And this is not the same case as we did here. This is not 5 minus 1 factorial, because if we look at the dodecahedron from another angle, from here to here, it will not look the same as it did when we didn't choose the top 5 and we were choosing the bottom 5s, because since the bottom 5s are now chosen, the colors will be different if we look at it from another angle, right? I hope that makes sense. So that will just be 5 factorial. There are 5 faces left, so times 5 factorial. So let me rewrite this. This is equal to 11 choose 1 multiplied by 10 choose 5 multiplied by 4 factorial and 5 factorial. And if we actually calculate this, then what we will get is 7, 9, 8, 3, 3, 6, 0. This is what you'll get after you calculate all of this. So there are this many ways to color this dodecahedron. And now I'm going to show you guys how to do this in another way, which is a little bit faster. And so we have 12 faces in total, and we can arrange them in arrange them differently, I guess. So yeah, we can arrange them differently, and we have 12 faces, so that would be 12 factorial because we can do that randomly. But since we have 4 faces and it looks exactly the same whether you look at it from this angle, from this face or this face or this face, it does not matter. They all look the same, so we divide it by 12, and then we divide that by 5. Because if we set like for example this as the base, then we have 5 sides to look from. We have this side, this side, this side, this side, or this side. And so those are 5 sides that we can look from that look exactly the same. So that would be divided by 5. And if we calculate this, well, this is just 11 factorial divided by 5. But if we calculated this, we would also get the same thing, of course. 7, 9, 8, 3, 3, 6, 0. And this was the Dodecahedron. And technically there is like a formula to find for the total number of ways you can color this, and that would be the number of sides factorial. So let me write it up here. It would be the number of sides factorial divided by the number of sides again. Oh, I'm sorry, I meant the number of faces divided by the number of faces again. And once again divided by the number of sides of one face. So like one face in our dodecahedron was a pentagon which has 5 faces. So I don't know how to write that, but I guess I can just put any shape. So that would be the formula to hunt for it. For any Platonic solid, I think. So that will be it for this video. Have a great day, and thank you for watching.